Image sampling and quantization. So here sampling is a different process and is different process. Together they combine a process known as converting continuous image into digital formats. Okay, so it allows for representing the images in a way that can be easily stored, processed, and displayed by digital systems. So here basic concept nothing but first the there is a component or a term we use as continuous image. What is an image can be represented as a continuous function, that is f of x comma y. We already saw that what is f of x comma y, special coordinates, and f is a amplitude. So with the help of this coordinate, we can display show the actual intensity of the gray scale or gray level. Okay. Then here objectives. The goal of simplifying and quantizing is to convert this continuous image into a digital image. Can be represented as discrete values. See, yes, this external special coordinates, the function value represents the intensity of bright or at that point understood. So there will be pixels, right? So these pixels are nothing but it will be so many pixels will be there, so many here, like exactly and so each pixel has its own brightness, right? So that is used for here that is used. So here first we will see what is sampling, and then we will see what is quantization, and then process of both how it works. Sampling is the process of selecting specific points from a continuous image. So we know already what is continuous image. Continuous image, we select a specific point and we create a discrete representation. This involves measuring the intensity of the regular intervals both at x and y. Okay, so what is sampling? Nothing but process of selecting specific points from a continuous image to create representation. Spatial sampling, this refers to the selection of spatial coordinates. For example, if you have continuous image, you it at regular intervals to create a grid of point. So you understand what is spatial sampling and normal sampling. Normal sampling is about selecting specific points. Spatial sampling is selecting spatial coordinates. So if you have this image, you might sample it to at regular intervals to create grids of points. Example, in one dimensional representation, you can take samples along line. So here is asked the sample along a line, and then what happens? It samples it, finds the coordinates here, samples into coordinates, special coordinates, and then only this data has been taken here, as you can see here. That's it. Quantization is the process of mapping the continuous amplitude values obtained from sampling into finite set of discrete values. We map this amplitude values to discrete values. So in simple words, is mapping all amplitude values to discrete values. Discrete values are finite set of discrete values. It involves dividing the range of intensity values into intervals and assigning a specific value at each interval. Intensity levels are there in this context is nothing but if you have a continuous range of intensity values, you might divide it into 8 discrete values levels. Example 0 to 255 for an 8-bit image. So intensity value is then assigned to the nearest discrete level. You don't have to like make it complex much. You just have to like explain the small part in this. If not also in this particular notes, you can simply try to like remove this any like if you just read this whole thing, you can simply remove a small generalized form also of that. Then we have process overview. So sampling and quantization. Sampling is about selecting points from the continuous image at regular intervals to create a discrete set of samples. Same thing above. Quantization, assign each sample value to a nearest discrete intensity level based on predefined intervals. Result what? The combining of sampling and quantization produces a digital image that can be represented as a matrix or a pixel value. What factors can affect? Noise can affect sampling rate, quantization levels. So see, noise can affect the accuracy. So higher noise levels may require more careful. That's it. Sampling rate is the number of samples taken per unit distance. So whatever the sampling rate you have done, you take a particular point and how much distance how much you are taking. So special reason, higher sampling rates leads to better image quality. Same for quantization level, the number of discrete intensity levels. Yeah, basically taking the power of to any number. So here what happens? It determines the intensity resolution of the image. So basically what you have to say, the number of discrete intensity levels allows more gradations in intensity but increase the degradation. It allows to improve the gradation, not the degradation but just gradation, and but it to increase in data size. Digital image can be represented as two-dimensional array, that is a matrix, or pixel values. So here each pixel corresponds to a specific intensity. Know all that always. Spatial domain. Even with the coordinates of the image are typically defined in a Cartesian coordinate system, the origin of the top left corner of the image. So your spatial. So here this is a coordinate representation. So suppose there is a box right at this corner here. This is the corner, so there that top left corner is nothing but the origin. From there the pixel starts. So basically if you can see my cursor, this is the end of the cursor, so where it is pointing is the first pixel like that. Dynamic range and contrast is nothing but ratio of maximum measurable intensity and minimal detectable intensity in the for various contrastion. If you see here, highest to lowest intensity level, that's the difference between there. The dynamic range is the ratio of minimum to minimum detectable intensity levels affecting the image quality. All this what is sampling, selecting discrete points from a continuous image to create digital representation. Quantization continuous intensity values to a finite set of discrete levels. Spatial resolution, higher the sampling rate, higher intensity resolution, more number of quantization levels, more finite intensity gradations. That's it. This is the question which can be asked, and then we'll move in the next video on this particular topic, which is actually very easy.